Good day, everyone. I am uploading this discussion covering Chapter 1 on the topic Introduction to Information Systems. Please reserve your questions, reactions, in our next synchronous meeting. Also, I have some validation activity for us to tell if we are effective in this discussion. The objectives are illustrated in this slide. I will not be going one by one on our contents, subtopics, and goals, but instead we will be validating the information here if we have achieved after the end of our discussion. So please go over na lang po later, and now let me go straight to the contents. So we'll have the definition of the operating system. An operating system is a program that manages the computer hardware. It provides basis for application programs. So in formality, we say that operating system acts as an intermediary between a computer user and the hardware, and that it provides an environment within which other programs to work. So we have here the operating system goes for us to execute the program, and that it is for the computer system to be very efficient and effective, use the computer hardware in an efficient manner. We have the computer system structure as to the different components. So we have to consider the basic components. Now, during your foundations, we say that the components of the computer systems is composed of computer, the hardware, you have the peopleware, you have the software. So that is our basic understanding on the computer system structure. Now, in this slide, we would like to deal with the structure. However, it is in the context of operating system. So in this case, we have the hardware. So by the hardware, we mean the physical component. It consists of the central processing unit, the memory, the input-output devices. It provides the basic computing resources for the system. We have the operating system, which is the lifeblood of the system. It controls and coordinates the use of hardware among various applications and users. We have the application programs. Ito yung kailangan mo na lang ng initiative. Kailangan mo mag-explore kung anong meron. No so much formality sa ibang application programs. The application programs define ways in which these resources are used to solve the user's computing problems. So, kilala natin sa application program. We have word processors, compilers, web browsers, database, even your computer games. The users. So, hindi lang tao po si users. If it is in the context of operating system, we mean that users are people, users are machines, or it could be an automated system. Now, we can also consider different views of the operating system. So we have the user's view, and we have the system's view. Ito, system's view. On the user's view, it may vary. Ano po yung consideration? According to the interface used. Some operating systems are designed for ease of use. Okay? Ease of use with some attention paid to performance and not paid to resource allocation. Now, these systems are designed to maximize resource utilization to assure that all available CPU time, the memory, the input-output are used efficiently, and that no individual user takes more than his share. So, ganun si system's view tumingin, yung internalities. These are multi-user systems where terminals are connected to mainframes or mini computers. So systems are designed where users can share resources and may exchange information. Well, in some cases, users makes use of the workstations. They are connected through the networks, and that it has servers, client-server environment. These systems have dedicated resources, maaari, such as they have dedicated printers, servers. The operating systems compromise individual usability and users' utilization. Yun yung kino-consider niya. The program that is most intimately involved with the hardware is the operating system. It is a program that runs all the time while your computer is working. The operating system, as we said, is a resource allocator. So, ano po yung mga kino-consider sa resource allocator? Yung pag-allocate ng CPU time, the memory space, the file storage, and input-output devices. Tandaan nyo po yan. We have the consideration of a resource allocator. Diba? Sinabi na natin kanina na maaring siya ay for systems and users view. Now, further, we say that the operating systems acts as the manager of these resources. What are the resources that we refer to? Kanina sinabi natin, we have the hardware, you have the software, so its internalities as well. So, a control program, by control program, the operating system manages the execution of users' programs to prevent errors and improper use of the computer. It is so much concerned with the operation and control of the input-output devices. Ganun po si OS natin pag nag-isip. Yung kanyang ginagawa is more on internalities. Okay, now as to the definition, kanina we define the term. As it is in the context, it is an intermediary between the hardware and the user of the program. However, there is no universally accepted definition. Okay? Maaring iba-iba po din ang kanilang pag-interpret ng operating system. Well, it needs the integration components. There are integrating components. As we said, we have the hardware, we have the software. The operating system is a system that is running all the time. The computer systems could be composed of one or more CPU. There are device controllers through the common bus. Yung, limbawa, nilalagay natin sa keyboard, with the bus, si mouse, nakakonect din kay bus, your printers, and many other peripheral devices. This, of course, accesses a shared memory. There are concurrency of executions of CPUs and devices which competes for memory cycle. Well, let us not forget the concept a while ago that the goal of an operating system is to execute programs and to make solving the user's problems easier. It is constructed towards this goal, and the hardware alone is not easy to use. Why? Because there are application programs that are also developed that is integrating with this resource. The programs require common operations such as controlling the input and output, which we use most of the time at mga devices. The common functions of controlling and locating resources are then brought together into one piece of software, which is your operating system. So the operating system is the one program running at all times on computer, usually called the kernel. Kilala din po siya as kernel. Okay, so let's proceed to the next concept. On computer startup, we consider bootstrap. So, for a computer to start running, it needs an initial program to run at boot time. What is this? This is also an attribute to operating system. So it makes your system running and that it starts at boot time. The initial program or bootstrap tends to be simple kasi it will start the initial programs. So it is stored, the bootstrap of your machine is stored in a read-only memory. It initializes all aspects of the system. The bootstrap must know how to load the operating system to accomplish that task. So the occurrence of an event is usually signaled by an interrupt from either a hardware or a software. So narinig na natin yan si interrupt, si system call from the software. Again, we have the bootstrap to initialize the program. Well, it's not only the program, but it initializes all aspects of the systems. The occurrence of the bootstrap is usually signaled by an interrupt from either a hardware or a software. So the hardware triggers by sending signal to CPU through interrupt. The software may trigger an interrupt through a special execution called system call. Computer system operation. So there are one or more CPU, there are device controllers. It connects through common bus, providing access to shared memory. We have to consider concurrent execution of CPUs and devices competing at memory cycles. So if you can check on the figure here, okay, so we have here the peripheral hardware. There are two classifications of hardware, by the way. So we have the system's hardware, the internalities, the circuitry, the motherboard inside your CPU casing, and the one that is connected through the cables to peripheral devices. We have associated devices like mouse, you have keyboard, the printer, the monitor. And of course, it's working because there are associated drivers. And these devices shares the computer's memory. So it could be a concurrent execution. It could be sequential. It could be a hybrid execution. Since only a predefined number of interrupts are possible, a table of pointers to interrupt routines is used to increase the speed. So, nakalagay siya sa table of pointers. So, there are arrays of pointers which is predefined. The table of interrupt pointers is stored in low memory. And these locations keep the addresses of the interrupt service routines for the various devices. Again, there are arrays for interrupts like interrupt vector that is indexed by a unique device number. So, kahit magsabay-sabay sila, sabay-sabay silang gumana, they are accommodated and they are organized because there is that unique device number for every devices used. The number is given within the interrupts request to provide the address of the interrupt service routine for the interrupting device. Like, ginalaw mo yung mouse, ginalaw mo yung nag-type ka sa keyboard. The CPU device controllers are in charge of each of these devices. So, meron po tayo mga CPU devices, or shall we say CPU and device controllers. The CPU, okay, the CPU in this case the CPU and device controllers are considered, and which these are executing concurrently, competing for our memory cycles. Okay, so we have the common functions or the common functions of the interrupt. So we have the predefined symbols, as we said, and then we have arrays, which is organized through our interrupt vector. The common functions of the interrupt. There would be some terms na magiging foundation po natin dito para maintindihan po natin si common functions of the interrupts. Now, first, a memory controller synchronizes access to the memory. Then, the bootstrap, ito kanina yung diniscuss natin, which is a simple, an initial program that runs when the computer is powered up and transfers control to the OS. So, ito yung mga foundations natin. In modern operating systems, it is interrupt-driven. Lahat ng operating systems gumagalaw. Lahat ng operating systems natin ay natitrigger because there is that interrupt-driven feature of the operating system. So, if there is nothing for the OS to do, it will wait for something to happen. Nasa idle siya, nagwe-wait siya. So, nag-aantay siya lagi ng interrupt. Events are almost signaled or at most signaled by an interrupt or a trap. Hardware interrupts usually occur by sending a signal to the CPU. So, may triggers na input, na click, merong entries. And there are considerations of the software interrupt. And ano po yung nagtitrigger sa software interrupt? That is by executing a system call. A trap is a software-generated interrupt caused by an error or a request from the program that an operating system service be performed. Okay, those are the common terms for us to understand the common functions of the interrupt. The interrupt handling. So, we have defined a while ago what an interrupt is. So, by interrupt handling, we mean that the operating systems preserve the state of the CPU by storing registers and the program counter. So, the register is the scratch pad of the CPU. So, bago yan mangyari, yung finalization, it has first to reside the operations, the initial operations, the trial and error will go to the registers. And, of course, on every inputs, there are considerations of the program counter. So, it's considers as to what type of interrupts, either vectored interrupt systems or pooling. So, we'll be discussing these details in the next chapter. So, for now, we have the interrupt concept, and these are the overview for now. We have the interrupt timeline. So, what do you observe on this diagram? There are responses. Okay? Responses, and that there are some cycles. So, some cycles could be idle. Some cycles are to make execution. So, there are responses coming from the input-output device and the CPU. So, as there is an input-output request, there are responses that will be made possible by the CPU. So, if it's idle or transferring, the CPU is awaiting for the transfer or the next execution. So, as the transfer is done, it's here, as the transfer is done, then the CPU will start on working on that specific transfer. It could be an activity that is to be processed, or it is on a waiting state. So, again, with this figure here, it's very transparent that the responses are triggered from the input-output device, and then the CPU will do something about the instructions coming from the input-output devices. The input-output structure. So, kung merong input, it is expected that As I was saying, on the input-output structure, if there are triggers, there are expected results. So we have to remember that each device controller is in charge of a specific type of device. So pag naglalagay ka ng camera, you need to install first the driver, because the driver will have its device controller, which will be operating and integrating its activity to the operating system. So hindi kilala si camera na may lens, pero the device driver kilala po ni operating systems yun. So silang dalawa yung nag-uusap-usap. There is that small computer systems, or the SCSI, which can have 7 or more devices attached to it. So a device controller maintains some buffer storage and set as there are a set of special purpose registers, so it moves data between the peripherals and its buffer storage. So we made mention about systems calls and interrupts. Ano yung mga input-output interrupts to be considered here? So when there is that starting input-output operation, the CPU loads the appropriate registers in the device controller. So the device controller examines the contents of these registers to see what action to take, and that once the transfer of data is complete, the device controller informs the CPU that it has finished by triggering an interrupt. So yun yung kanina pinag-usapan natin about interrupt. The storage definitions and notations. As to the hierarchy, we have the bit, then you have the byte, word, and of course now with bigger capacities. The general purpose computers run their programs from a random access memory, or our main memory. It is implemented using dynamic random access memory technology. So the interaction with memory is achieved through a sequence of load and stores instruction to specific memory addresses. Paano nangyayari yon? Load instructions move from a word to main memory to an internal register within the CPU. It stores instruction and then moves content to a register of a register, moves content of a register to main memory. The CPU automatically loads instructions from main memory for execution. Okay? So, sa instruction execution cycle naman, it fetches the instruction from main memory or RAM, and stores instructions to the instruction register. Then it decodes instructions and make cause operands to be fetched from memory and store in some internal register. So after the instruction for the operands, it then gives its result back to main memory. Okay. The direct memory access. Kaya direct memory access po siya dahil it bypasses the CPU. So instead of passing through the CPU, si CPU gagawa na lang ng ibang jobs, kasi si input will go directly to the memory. On the storage structure, so kanina we have the processes input. Pagkasunod sa input, we have process, and then we have on the storage. So the main memory. The main memory is very limited, and it's most of the time during the operations, the memory unit only sees a stream of memory addresses. It doesn't know that they are generated. So we are interested only if the sequence of memory addresses generated by the running program. Ideally, we want programs and data to reside in the main memory kasi nga mabilis, but it is not possible for so many reasons. Ano yung mga reasons na yon? Kasi it's too small. That main memory, our RAM, is too small to store all the needed programs and data permanently. Main memory also is volatile. Nawawala po yung kanyang contents the moment it is turned off or wala po tayong power. For this reason, most computer systems provide secondary storage device as an extension to main memory. Dahil may limitasyon, ayan, sasagutin ni storage device. The main requirement of a secondary storage, is that it must hold large quantities of data. Most of our common storage device are magnetic tapes, we have CDs, we have flash memories, and of course there are storage systems that may vary in speed, cost, size, and volatility. Yun yung mga factors na dapat nating pag-usapan. Okay, so we have these factors. Accordingly, meron po tayong speed, cost, and volatility. Ngayon, ikukumpara natin yan, yung factors na yan dito sa figure na yan. We have registers, cache, main memory. Ito yung nasa RAM, di po ba mabibilis. Kaya lang, with the limitations discussed kanina, it's not permanent. Now, in the next, we have solid state disk, magnetic disk, optical disk, magnetic tapes. Ito naman po yung secondary storage device, which we have, if we are to consider factors like speed, syempre mas mabilis po yung nasa main memory compared to secondary storage device. When we are to consider factors like volatility, ito si register, si cache sa main memory, it's temporary. Solid state, magnetic disk, optical disk, magnetic tapes, it's permanent. So when it comes to cost, ang mamahal din po ng ating fast storage devices. Si solid state devices, magnetic disk, it may vary in the price. So when it comes to prices or cost, so we have the vendors that will help us analyze these factors. Next, on the concept of computer system architecture. So, dapat nating tandaan that we have the terms like tingin ulit si Cash na wala dito muna. So, computer systems architecture, we have asymmetric processing, only one processor accesses the system, and that is one master processor that runs the OS. There is that master-slave relationship. Si symmetric processing naman, it shares the memory. So, ang daming gumagalaw na mga processors, and that is sharing the memory. Okay. Next, we have the DMA, or the direct memory access. It doesn't go to the CPU because it goes directly to the memory. So, it started from the input, then it proceed to the output operation, and thus, hindi na masyadong dinisistorbo si ating memory. Si CPU, I mean. Si CPU po can still be accommodating jobs instead of accommodating only the input and the output. So, it can be very efficient because it can work simultaneously with this DMA structure. Now, in the figure here, ano nakikita natin sa figure na to? We have multiple processors, and it shares the resources of the memory. Well, it's not only memory. In most cases, may bus, may clock. This is for symmetric multi-processing architecture. We have the concept of dual core design. Okay, so anong ibig sabihin ng mga acronym na to? UMA stands for Uniform Memory Access. Uniform Memory Access. Non-Uniform Memory Access for NUMA. Ito po yung mga considerations po natin sa dual core design. So, we have core 1, you have core 2, sharing, memory, and other resources na na-mention po natin kanina. On clustered systems. Clustered, like distributed systems. So, there are multiple processors to be considered, and there are parallel jobs working simultaneously. On clustered systems, we have this structure. So, we have several computers sharing the storage area network or these resources. Okay, it's parallel systems. There are actions taken simultaneously through these workstations. Next is operating system structure. So we have topics multi-programming and time sharing. So when we speak about on operating system structure, so there are two important things for us to remember about the operating structures with the features of multi-programming and multi-sharing. So, ano pong pinanggalingan ng ating topic na to? Remember a while ago that we made mention about clustered systems. So, with the features of clustered systems, we say na we have multi-programming, that is to increase CPU utilization by organizing jobs so that the CPU always has things to do. It makes use of the processes, and that the operating systems have several jobs in memory and begins to execute one of them until it has to wait for the next task. We also have the concept of multi-sharing, or shall we say multitasking, time sharing. So that's the concept. Time sharing means many users can share the computer simultaneously. So the CPU switches among multiple jobs so frequently that users can interact with each program while it is running. So ano yun? So we have here the layout, no? So the implication is in multi-programming systems, jobs are allocated by the operating system. So with the consideration of the distribution of shared memory. Okay. So bumalik. The operating systems operations. So as previously discussed, operations are categorized as maybe responses triggered by hardware or software. There are possible errors, however, cascaded to users through a trap. Next, we have the transitions. Okay, so with the transitions to activate or trigger the operating system's operations, it has to originate from the user mode, and that is bit 1. Kernel awaits from the user processes, and kernel is bit 0. So before that, it has this instruction to be carried. Kanina nag-usap po tayo about input. We have now the process. So the process is a program in execution. Sometimes we hear this associated term, passive entity or active entity. It is the dispatchable unit. Executions are organized with a program counter specifying the queue with the considerations of the executions, and then we have the status properties. So, yun ang dapat nating tandaan when it comes to process management. Process management involves the described tasks here. So we have the process operations that are controlled and implemented by the process control block. Okay, so these are the set of processes na dapat nating tandaan. Kaya niya mag-create, mag-suspend, then the mechanisms for process synchronization, communication, and deadlock handling. Okay, yung pag-consider din ng mga conflicts for deadlock handling. The memory, or shall we say, you have the storage management. Tingin, memory management muna. Memory management is the process of controlling and coordinating the computer memory. So, we assign portions of block and optimize the overall performance of the system. So, memory management resides in the hardware and also in programs. Okay? Storage management refers to the management of data storage equipments that are used to store the generated data. So, memory management is for consideration, the considerations of operations as well. Next, we have the storage management, yung file organizations that requires bigger memory space, and these are all permanent storage. Sorry, napapabilis yung mouse. Okay, so next we have the consideration of mass storage device. Kanina, we have memory storage. Pag sinabi naman natin mass storage, there are technologies and devices in storing large amount of data. So, this includes solid state drives. You have your external hard drives. Okay. So, meron po tayong guide dito for you to have the point of comparison. We have the memory. Second, the primary storage, we have the secondary storage, and its point of comparison as to typical size, implementation technology, the comparison of the access time, its speed as well. Okay. We have the consideration from magnetic disk, communications initiated from magnetic disk, then cascading back to main memory, to the cache, and the hardware register. So these are the consideration of operations from one device to another. The input-output subsystems. May ibig sabihin ng input-output subsystems, we are concerned with the standard interfaces for a wide range of devices, and that is making devices easier to add in existing systems. So we do add hardwares with these drives. So as the input-output subsystem is considered, ibig sabihin yung operating systems has to work hand in hand. Tulad nung merong issue sa OS from, say, the devices, the hardware devices, si Vista, si operating system nagbago. So sometimes si hardware na-apektuhan din. If it's not compatible, nag-dispose ng mga hardwares during Vista time, the migration of Windows Vista, there are issues on hardware. So na-dispose yung kanilang mga input-output devices kasi they have to replace it with hardwares that is compatible to Vista. Next, on protection and security. Trabaho din ni operating system ito, si protection and security. Security is providing a protection to computer systems resources such as CPU, memory softwares, computer programs. We assure that the operating system is to assure that authorized user can access the system. Also, it is free from malicious programs like virus, worms, yung mga threats sa ating hardwares and softwares. On the structures here, tignan nyo yung illustration, it describes the process created by the system. So, kernel data structure is created containing the details of each of these processes. Okay. Next, we have the consideration of the data structures. So, some of you were able to take data structures, and there are considerations of nodes that contains information. The root kernel data structures and its branches here are the consideration of the process table, the file table, and the nodes table. Next, tignan natin kung ano pa po yung mati-describe. Okay, so we have the hash functions. Naalala nyo yung pag nag-data structure, file systems, may mga concept ng hash functions. This can be used to map data and its properties. So, we have parent-child processes, and that is for the purposes of storage and retrieval, kung paano po yung sistema. The computing environments. So, what are the surroundings? So, like for example, meron tayong computing environments as to mobile, and that we consider emergent systems considering its capability and functionalities. Okay, so merong mga traditional din, yung pag sinabi natin traditional, you have the standalone systems, ibig sabihin it's not connected to any other systems. Minsan, si standalone systems, may mga ano po tayo, provisions where they can share resources, and that it will cascade to portals, network computers. We have client-server environment on its extent. Si mobile, kanina we made mention ahead of the mobile kasi ito yung technology ngayon. We wanted the computer to be portable. So, sa ngayon, on emergent systems, we make use of our handheld devices. So, si handheld devices, meron din siyang operating systems na siya po yung nagmamanage ng mga interactions ng mga applications. On distributed systems, we do consider here two-tiered approach. You have the client and the server, or the kaya it extends to the database on a three-tiered approach. This is about sharing of resources. Okay, so we have the client server environment, and this is okay, wag po matulog ha. Absorb nyo po yung lesson na to para sa second chapter po mas mabilis po natin itong relate. So, on a client-server environment, there are service working interactively with the different workstations. So, when we speak about workstations, this could be machines, personal computers. We have also our environment working like mobile, and then, of course, resources like sharing of data. Are all integrated in the operating systems. And on the environments, let us not only focus on the resources but the protocol behind it. Like we have the topologies of the network with a guided protocol working closely with the operating system. It makes it possible to operate. Then we have concepts on resource provisioning, the version of creating something, including virtual computer as may be extended to another resource host. The computing environments on virtualization. So ito yung the operating systems natively compiled for CPU running guest OS. So kung ginagawa natin na pag halimbawa ang ating system ay gusto natin magkaroon ng maraming operating system kasi si isang machine, isang operating system na talaga siya. So that's why nga kung meron kayong computer, so either you have the Microsoft or di kaya mag-Mac, pero nevertheless na si Mac at saka si Microsoft ay nasa isang machine. This is possible kung kayo ay maggagawa ng bare machine, virtual machine, na the other one is the operating system, and on an extension meron po kayong virtual machine na naka-install po yung isang operating system, and of course all other programs. Ginagawa din siya in the limitation halimbawa of the system na hindi ganun kaganda yung specs. Gusto mong gumamit ng Oracle pero hindi naman ganun kaganda ang specs ng iyong computer. So, you can always consider virtualization para ma-extend po yung capability. So, it's an illusion na you have these resources. Pero, the operating system makes use of some provisions para ma-accommodate po siya even with the consideration of limitation. Of course, ito ay introduction lang po. Lahat ng mga pinag-uusapan natin dito, mga introduction lang kasi may mga chapters po talaga na iniisa-isa po natin lahat ng mga concepts ng OS na to. Okay. Next, we have, yes, the concepts on virtualization na you have this machine. However, it's extended to your hardware extended to a virtual machine, and that's creating several kernels, several virtual machines on these provisions. So the virtual machine is a technique that allows the execution of a job that may not be completely in the memory. So the advantage is that the programs can be larger than the physical memory. There is the time sharing known as the file system capability sa bawat kernels, and that the file system resides on a location of a disk. There is also a separate disk management on virtual memory. Okay, so that's for the introduction for now. The cloud computing on demand, availability of computer resources, especially on data storage. So, yun po yung pinaka titingnan natin dito. Like, you have the public cloud, the private cloud, the hybrid cloud. On cloud computing, we have to consider the several environments like client-server environments. Environment like virtual machines is also considered cloud. compute environments composed of traditional operating systems plus the virtual machines plus cloud management tools. So, ang daming interconnectivity na kinoconsider ko dito. So, this is an application of the cloud distribution. Next, we have the real-time embedded systems. Real-time, ibig sabihin, these are responses in a very short time. So, pag ikaw halimbawa nag-create ng isang process, immediately the processes should be transmitted or transformed into results. Katulad niya, nagde-deposit kayo ng cash. Pag na transact yung pag-deposit na yan, kailangan meron po kaagad response na ay nandun kaagad sa account niya. Pag tumatawag ka sa cellphone or ringing this at 5:01, exactly, nagre-response din po yung ating sender and recipient on that real time. And that's fast span of time. Also, there are considerations of open source operating systems. So, operating systems that is made available in source code. May mga experts na nagko-collaborate para magawa si open source operating systems. If there are problems, if there are issues, so experts tulong-tulong po sila sa pag-aayos. And of course, ang pinakakilalang operating systems na ginagamit halos ng lahat are the licensed one, katulad ni Mac or si Windows. Now, lahat ng yan, be it open source or licensed operating systems, this makes up the system na meron po tayo sa ating mga machines. So, on an implementation, pwedeng license, pwedeng open source, taking into consideration its advantages and advantages. Ang pinaka iniisip po natin that there should be a provision for us to use the hardware and the software, whatever we want to trigger, whatever we want to operate, kailangan may provisions po sa hardware and software. This operations na gusto natin mangyari is made possible because there is that operating system that is integrating on the hardware and the software. So that's it for chapter 1.